Hello, guys. Welcome back to Hold On, Survival Stories. I'm your host, and how are you all doing today? I hope you're having a great day and you're ready for another incredible survival story, because today's episode is going to be absolutely mind-blowing. Before we dive in, I want to thank everyone who liked and subscribed after our last episode about the apartment fire rescue. Your support means the world to me and helps us bring you these amazing stories every week. And for those of you who are new here, make sure to hit that subscribe button because, trust me, you don't want to miss what we have coming up. Now, today we're taking you deep underground for a story that will show you just how quickly a routine job can become a fight for survival. This story will demonstrate how industrial knowledge and quick thinking can mean the difference between life and death, how the human spirit can endure in the most suffocating circumstances, and how sometimes the earth itself can become both your enemy and your ally. You'll witness how 30 hours in a collapsing mine shaft can test every survival instinct, and how the determination to see loved ones again can keep someone alive when buried under tons of rock and earth. This is the story of 28-year-old Marcus Rivera, a construction safety inspector who became trapped 150 feet underground when an abandoned mine entrance collapsed, and how his engineering knowledge and unbreakable will to survive turned a potential tomb into a temporary shelter. By the end of this story, you'll understand why staying calm under pressure, using your professional skills creatively, and never giving up hope can overcome even when you're buried alive beneath the earth. So grab your favorite drink, get comfortable, and let's dive into this incredible tale of survival against all odds. Tuesday morning, September 19th, 2023, started like any other workday for Marcus Rivera as he drove his company truck through the mountainous terrain of West Virginia's coal country. The 28-year-old construction safety inspector for Consolidated Mining Solutions had been assigned to conduct a routine structural assessment of the old Blackwater mine, an abandoned coal operation that the company was considering for potential reclamation and redevelopment. Marcus had been working in mining safety for 6 years, ever since graduating from West Virginia University with a degree in mining engineering. His job took him to abandoned mines throughout Appalachia, evaluating structural integrity, environmental hazards, and the feasibility of converting old mining sites into commercial or recreational properties. It was a demanding work that required both technical expertise and physical courage, as abandoned mines could be extremely dangerous places, filled with unstable structures, toxic gases, and unpredictable geological conditions. The Blackwater mine had been closed since 1987, when declining coal prices and environmental regulations made the operation economically unviable. For 36 years, the mine had sat abandoned, its entrance sealed with concrete barriers that had weathered and cracked over the decades. Recent heavy rains had raised concerns about structural stability in the area, and Marcus's company had been contracted to assess whether the old mine posed any risks to the new housing development planned for the valley below. That morning, Marcus followed his usual pre-inspection routine with the methodical precision that had kept him safe during hundreds of similar assessments. He checked his equipment, a high-powered LED headlamp with backup batteries,
a portable gas detector to monitor for methane and carbon monoxide, a digital camera for documenting conditions, measuring tools, and his emergency radio. His lunch consisted of 2 sandwiches, an apple, a bag of chips, and a thermos of coffee. Fuel for what he expected to be a 4-hour assessment. Marcus's inspection plan was thorough and conservative. He would enter only the main tunnel, extending no more than 200 feet into the mine, and would continuously monitor air quality and structural conditions. He had filed his safety plan with his supervisor, Jake Morrison, showing his intended route and estimated timeline. According to the plan, Marcus would enter the mine at 10 a.m., complete his structural assessment by 1 p.m., and be back at the office by 3 p.m. for his afternoon meetings. "Remember, Marcus," Jake had emphasized during their Monday planning session, "this is just a preliminary assessment. Document what you can see from the main tunnel, take your measurements, and get out. We're not looking for heroes. We're looking for accurate safety data." Marcus had nodded, understanding the wisdom in Jake's caution. Abandoned mines were inherently unpredictable environments where decades of neglect could create deadly hazards with no warning. Water infiltration, roof deterioration, and ground settling could turn a seemingly stable mine into a death trap in seconds. What Marcus didn't know, what the engineering reports and geological surveys hadn't detected, was that the recent heavy rains had done more than just raise water levels in the area. The water had infiltrated the clay and shale layers above the mine entrance, creating hydraulic pressure that was slowly destabilizing the rock formations that had supported the tunnel entrance for over 30 decades. At 9:45 a.m., Marcus parked his truck at the access road where the old mining company had built a gravel turnaround for equipment. He sent a quick text to Jake, arrived at Blackwater site, beginning inspection as planned. The morning was cool and overcast, with a light mist hanging in the valleys between the forested hills. The abandoned mine entrance was a dark, rectangular opening carved into the hillside, partially hidden by overgrown vegetation and guarded by rusted warning signs that read, "Danger, abandoned mine, keep out." Marcus took a moment to study the entrance from a distance, looking for obvious signs of instability or structural problems. The concrete barriers that had once sealed the entrance had indeed deteriorated significantly, with large cracks and gaps that would allow easy access to the integrity. More concerning were the fresh rock fragments scattered around the entrance, evidence of recent geological activity that suggested ongoing instability in the area. He performed his final equipment check, testing his headlamp, calibrating his gas detector, and ensuring his radio was set to the proper emergency frequency. At exactly 10 a.m., Marcus clipped his gas detector to his belt, adjusted his hard hat, and stepped into the entrance of Blackwater Mine. The tunnel immediately opened into a larger chamber that once housed mining equipment and served as a staging area for the underground operations. Marcus's headlamp beam revealed timber supports that were still in remarkably good condition, massive steel I-beams that spoke to the engineering quality of the original construction, and railroad tracks that disappeared into the darkness deeper in the mine. As he began his assessment, taking measurements and photographs, Marcus noted that the mine was remarkably well preserved. The air quality was good. His detector showed normal oxygen levels and no dangerous gases. The timber supports showed some weathering but appeared structurally sound. The main tunnel extended straight into the hillside with minimal curvature, supported by a combination of natural rock formations and engineered timber frameworks. At 10:15 a.m., Marcus was 50 feet inside the mine, documenting the condition of the timber supports and measuring tunnel dimensions when he heard something that made every instinct in his body scream danger. The sharp crack of failing rock, followed by a low rumbling that seemed to come from the earth itself.
By 11 a.m., 2 hours after the collapse, Marcus had completed his assessment of the accessible mine area and faced a harsh reality. There was no obvious escape route. The shaft with the air current was too deep and steep to climb without equipment, and the rockfall blocking the main entrance appeared to be massive and solidly wedged. But Marcus's engineering training now became his greatest survival asset. Unlike someone without technical knowledge, he understood the mechanics of mine collapses, the behavior of support structures, and most importantly, how to assess and manage the atmospheric hazards that killed more trapped miners than structural failures. At 11:15 a.m., Marcus made several critical decisions that would prove vital to his survival. First, he moved his base camp to the area near the air shaft, where ventilation was best and carbon dioxide buildup would be minimized. Second, he began implementing a strict conservation program for his food supplies, calculating that he needed to make them last at least 24 hours, possibly longer. Most importantly, Marcus began using his engineering knowledge to solve practical survival problems. He noticed that water was seeping through cracks in the rock walls, the same water infiltration that had probably caused the collapse in the first place. Using his lunch thermos as a collection container, he began gathering the seepage water, which would supplement his limited liquid supplies. Marcus also used his understanding of structural engineering to assess the stability of his underground shelter. The timber and steel supports were holding, but he could see stress fractures in some of the wooden beams and hear occasional settling sounds that indicated ongoing structural movement. He identified the safest areas of the mine chamber and marked them with chalk from his equipment kit. At 12 p.m., when Marcus should have been completing his inspection according to his original plan, he was instead rationing his first sandwich, eating only half and saving the rest for later. The familiar taste of turkey and mustard helped boost his morale, but he was already beginning to feel the psychological weight of his situation. The first major psychological challenge came at 1 p.m., when Marcus realized that his supervisor, Jake, would be expecting him back at the office in 2 hours for their scheduled afternoon meetings. The thought of his normal work routine, his colleagues sitting in conference rooms, and the surface world continuing without him created a profound sense of isolation and disconnection. Marcus fought off the despair by focusing on technical problems he could solve. Using his engineering knowledge, he began calculating the likely volume of the rockfall blocking his exit. Based on the dimensions of the tunnel entrance and the extent of the collapse he could observe, he estimated that approximately 500 to 800 cubic yards of rock and debris were blocking his path to freedom. This calculation was both sobering and helpful. It told Marcus that clearing the blockage would require heavy machinery and probably days of careful work using specialized equipment to prevent further collapses. But it also gave him concrete information that he could communicate to rescuers once contact was established, potentially helping them plan more effective rescue operations. At 2 p.m., Marcus heard something that made his heart race with hope. The distant sound of diesel engines echoing faintly through the rock. Jake Morrison had arrived early for their 3 p.m. check-in, found Marcus's truck at the mine site, and discovered the collapsed entrance. Following proper emergency protocols, Jake had immediately called for mine rescue specialists. Marcus began systematically tapping on the steel I-beams and tunnel walls, using a wrench from his equipment kit to create rhythmic metallic sounds that might penetrate through the rockfall. The tapping pattern he used was based on standard mining emergency signals: 3 short taps, 3 long taps, 3 short taps, the international distress signal in Morse code. At 2:30 p.m., Marcus heard the most beautiful sound of his professional life, answering taps from the other side of the rockfall. Rescue workers had heard his signals and were responding with their own coded messages, indicating that they had located him and were beginning rescue operations. What followed was a primitive but effective communication system. Marcus would tap questions or information using mining emergency codes, and the rescue team would respond with their own signals. Through this laborious process, Marcus was able to communicate that he was uninjured, had limited supplies, and was experiencing good air quality but slowly rising carbon dioxide levels. The rescue team's response was both encouraging and sobering. They estimated that clearing the rockfall would require 12 to 18 hours of careful work using specialized equipment to prevent further collapses. Marcus was facing at least 1 full night underground, possibly longer. As the afternoon wore on, Marcus could hear the sounds of heavy machinery arriving at the surface and the beginning of systematic rock removal operations. But he also noticed that his gas detector was showing steadily increasing carbon dioxide levels, indicating that his air quality situation was slowly deteriorating. At 4 p.m., 6 hours after the collapse, Marcus made another critical engineering decision. He began constructing a simple air circulation system using debris and his understanding of fluid dynamics to direct the fresh air from the shaft more efficiently through his confined space. It was improvised engineering at its most basic level, but it was the kind of creative problem-solving that could keep him alive.
The sound started as a subtle groaning from somewhere above Marcus's head, but it quickly escalated into something much more ominous. His mining engineering training immediately told him what was happening. The roof structure was failing, and he had perhaps seconds to react before a catastrophic collapse began. Marcus's 6 years of mine safety experience kicked in instantly. He dropped his measuring equipment and ran toward the mine entrance, his headlamp beam bouncing wildly as he sprinted along the railroad tracks. But the collapse was faster than any human could run. Behind him, he could hear the thunderous crash of massive rock formations falling, each impact shaking the ground beneath his feet and filling the tunnel with choking dust. The collapse started at the entrance and worked its way inward like a deadly wave. Marcus threw himself behind one of the massive steel I-beams just as a boulder the size of a refrigerator crashed down exactly where he had been running. The beam held, but the impact sent vibrations through the entire support structure that made Marcus's teeth rattle. For what seemed like an eternity, but was probably less than a minute, the mine filled with the deafening sound of falling rock, splintering timber, and crushing metal. When the last boulder finally settled and silence returned to the underground space, Marcus found himself in a completely transformed world. Coughing and spitting rock dust, Marcus carefully assessed his situation. He was alive and apparently uninjured, protected by the steel beam that probably saved his life. But as the dust began to settle and his headlamp beam penetrated the haze, he saw the devastating reality of what had happened. The tunnel behind him, his only route to the surface, was completely blocked by a solid wall of rock and debris that extended from floor to ceiling. Marcus's heart rate spiked as the full implications hit him. He was trapped 150 feet underground, behind what appeared to be hundreds of tons of fallen rock, in an abandoned mine that no one was scheduled to visit for months. His radio, which he immediately tried, received only static. The rock above him was too thick and unstable to allow any signal to penetrate to the surface. Fighting down the panic that threatened to overwhelm him, Marcus forced himself to think logically. He was alive, he was uninjured, and he had some supplies. His mining engineering training had taught him that the first hour after a mine emergency was critical. This was when clear thinking and proper decisions could mean the difference between survival and death. Marcus checked his watch, 10:17 a.m. According to his inspection plan, he wouldn't be considered overdue until 3 p.m., still more than 4 hours away. That meant rescue efforts wouldn't even begin for several hours, and then rescuers would need time to reach the mine, assess the collapse, and begin the complex process of clearing the debris. Marcus methodically inventoried his resources. His headlamp showed full battery power, and the backup batteries would provide approximately 12 additional hours of light. His emergency supplies consisted of his lunch, 2 sandwiches, an apple, chips, and a thermos of coffee. He also had his portable gas detector, which was crucial for monitoring air quality in the confined space. The most critical issue was air quality. Marcus knew that abandoned mines could be death traps, not just because of structural collapses, but also because of atmospheric hazards. Carbon monoxide, methane, and oxygen depletion could kill him long before rescue arrived. He immediately checked his gas detector and was relieved to see normal readings, but he knew that could change quickly in a confined space. At 10:25 a.m., 8 minutes after the collapse, Marcus made his first critical survival decision. He would systematically explore the accessible portion of the mine to assess his situation, document his surroundings for potential rescue information, and look for any alternative escape routes or sources of fresh air. What Marcus discovered over the next hour was both encouraging and terrifying. The section of mine where he was trapped was approximately 100 feet long and 15 feet wide, with a ceiling height of about 8 feet. The timber and steel support structures had held during the collapse, creating a stable underground chamber. But more ominously, his gas detector was beginning to show slight increases in carbon dioxide levels, indicating that air circulation had been significantly compromised by the collapse. At 10:45 a.m., Marcus made a discovery that would prove crucial to his survival. Following the railroad tracks deeper into the mine, he found that they led to a shaft that had once been used to lower equipment and materials to deeper levels of the mine. The shaft was approximately 20 feet deep and had been partially filled with debris over the years. But more importantly, Marcus could feel a slight air current flowing through the space. The air current suggested that somewhere in the deeper levels of the mine, there were connections to the surface or to other parts of the mine system that hadn't been sealed. This was both good news and bad news. Good because it meant fresh air was still entering his confined space, but bad because it suggested the mine system was more complex and unstable than his preliminary research had indicated. Marcus sat down on a railroad tie to think and conserve his energy. He was now more than an hour into his underground ordeal, and he needed to start making some hard decisions about resource management, survival strategy, and communication with potential rescuers.
As the sun set on September 19, 2023, Marcus Rivera faced his first night trapped 150 feet underground. The psychological challenge of this transition was enormous. While he couldn't see the difference between day and night in his underground prison, knowing that darkness had fallen on the surface world above intensified his sense of isolation and vulnerability. At 6 p.m., 8 hours after the collapse, Marcus could hear that the rescue operation above was continuing with powerful floodlights, but progress was necessarily slow. Mine rescue specialists had to carefully analyze each rock before moving it, ensuring that removal wouldn't trigger additional collapses that could make his situation worse or endanger the rescue workers. Through their tapping communication system, Marcus learned sobering details about his situation. The collapse had been triggered by water infiltration that destabilized a key support formation near the mine entrance. The rescue team estimated that approximately 600 cubic yards of rock and debris were blocking his exit, confirming Marcus's own engineering calculations. More troubling, geological surveys indicated that the entire entrance area remained unstable, requiring extreme caution during the rescue operation. Marcus's biggest challenge during the first night was managing his deteriorating air quality. His gas detector showed carbon dioxide levels that were elevated but not yet dangerous, around 1.5%, well below the 3% level that would cause immediate health problems. But the steady upward trend was concerning, and Marcus knew that if CO2 levels reached 5% or higher, he would face serious risks of unconsciousness and death. Using his engineering knowledge, Marcus implemented several strategies to improve his air quality situation. He moved his base camp closer to the air shaft and used debris to create a crude ventilation system that would direct fresh air toward his resting area. He also began conserving energy to reduce his oxygen consumption and CO2 production, limiting his movement and activities to essential functions only. At 8 p.m., Marcus received communication through the tapping system that boosted his morale significantly. His wife Elena and his parents had been notified of the situation and were at the surface coordinating with rescue teams. Elena, a nurse at the local hospital, was providing medical consultation about underground survival and helping to plan for Marcus's medical needs once he was extracted. The knowledge that Elena was nearby, working to help rescue him, gave Marcus an emotional anchor that helped him fight off the despair and claustrophobia that threatened to overwhelm him during the long night hours. He found himself talking aloud to Elena during the darkest periods, sharing memories of their life together and making promises about things they would do once he was safely back on the surface. At 10 p.m., 12 hours underground, Marcus faced his first serious crisis. His gas detector alarm went off, indicating that carbon dioxide levels had spiked to 2.8%, approaching the threshold where cognitive impairment could begin. The increase appeared to be caused by a shift in air circulation patterns, possibly due to the rescue operations disturbing the underground airflow. Marcus immediately implemented emergency protocols he had learned in mine safety training. He moved to the area with the best air circulation, began controlled breathing exercises to minimize CO2 production, and used his tapping communication to alert the rescue team about the atmospheric emergency. The rescue team's response was swift and professional. They temporarily suspended their drilling operations to allow air circulation patterns to stabilize, and they began pumping fresh air into the mine system through a small diameter hole they had managed to drill through the rockfall. The fresh air injection brought Marcus's CO2 levels back down to safer ranges within an hour. At midnight, marking the end of Marcus's first day underground, he allowed himself a small meal, the second half of his first sandwich, and a few sips of coffee that had long since gone cold but still provided psychological comfort. He was now 14 hours into his ordeal, but rescue operations were progressing steadily and his life support situation was stable. But Marcus also faced the reality that he had at least another 8 to 12 hours underground. He needed to pace himself mentally and physically for what could be an extended survival situation. The combination of stress, limited food, poor air quality, and complete isolation was beginning to take a cumulative toll on his body and mind. At 2 a.m., during the darkest hours of the night, Marcus experienced what mine rescue specialists call underground syndrome, a sudden onset of acute claustrophobia and panic triggered by the psychological pressure of being buried alive. The attack began when Marcus started calculating how much rock and earth was above his head, thousands of tons of mountain pressing down on a small underground chamber that could collapse at any moment. Marcus's training and engineering knowledge saved him during this crisis. Instead of fighting the panic, he used breathing techniques he had learned in mine safety courses and focused his mind on technical problems he could solve. He recalculated the structural load factors for the support beams above him, analyzed the water seepage patterns on the walls, and mentally reviewed the rescue operation procedures that were being used to free him. The panic attack lasted about 30 minutes, but Marcus recovered and used the experience to develop better mental strategies for coping with his underground confinement. He began thinking of the mine not as a tomb, but as an engineering problem that could be solved through systematic application of knowledge and careful planning. At 4 a.m., 18 hours after the collapse, Marcus received news through the tapping communication system that gave him hope. The rescue team had successfully removed about 40% of the rock blocking his exit and could now see evidence of the steel support structures that were protecting his underground chamber. They estimated that he was only about 30 feet away from the edge of the collapse zone.
September 20th brought no light to Marcus's underground world, but it did bring renewed sounds of heavy rescue equipment and the voices of fresh rescue team members who had arrived during the night. At 6 a.m., 20 hours after the collapse, Marcus could hear the rhythmic operation of pneumatic equipment and hydraulic systems that indicated the rescue operation was entering its most intensive phase. Tap, tap, tap. Pause. Tap, tap, tap. The rescue team was communicating that they had brought in specialized equipment overnight and were beginning final approach operations. Marcus responded with his own coded taps, indicating that he was still in good condition but experiencing elevated carbon dioxide levels. The sound of the heavy rescue equipment was both encouraging and terrifying. Marcus could feel vibrations through the mine floor that indicated massive machinery working above him, but he also worried that the vibrations might destabilize the support structures that were keeping his underground chamber intact. His fears proved justified when, at 8 a.m., a section of timber support about 20 feet from his location suddenly cracked under stress, sending a shower of rock fragments cascading down from the ceiling. The failure was minor compared to the original collapse, but it reminded Marcus that his underground shelter was still precarious and that rescue operations might actually be increasing his immediate danger. At 9 a.m., 23 hours underground, Marcus faced his most serious physical crisis. His limited food supplies were nearly exhausted. He had only half a sandwich and a few chips remaining, and his water situation was becoming critical. The seepage he had been collecting provided barely enough water to maintain basic hydration, and the minerals in the groundwater were causing stomach irritation.
More seriously, Marcus was beginning to experience symptoms of carbon dioxide poisoning, despite the fresh air being pumped into the mine. His CO2 detector showed levels fluctuating between 2.5% and 3.2%, and Marcus was feeling mild headaches, dizziness, and difficulty concentrating. These were early warning signs that could progress rapidly to unconsciousness if air quality didn't improve. Using his engineering knowledge, Marcus realized that the rescue operations were creating dust and debris that was interfering with the airflow systems. He communicated this information to the rescue team through their tapping system, providing technical details about airflow patterns that help them modify their approach to minimize atmospheric disruption. At 10 a.m., exactly 24 hours after the original collapse, Marcus received communication that thrilled and terrified him. The rescue team had broken through to within 10 feet of his location and could now communicate with him using voice instead of tapping. But they had also discovered that the final section of rock removal would be the most dangerous, requiring precision work to avoid triggering a secondary collapse that could crush both Marcus and the rescue workers. "Marcus, this is Captain Sarah Williams with the State Mine Rescue Team. Can you hear me clearly?" "Yes, I can hear you," Marcus replied, his voice hoarse from 24 hours of underground confinement. "It's good to hear a human voice. Marcus, your wife Elena is here with us. She wants you to know that she loves you and that we're going to get you out of there safely." The emotional impact of hearing about Elena's presence was almost overwhelming. Marcus had been maintaining his composure through engineering discipline and technical focus, but the reminder of his personal connections to the surface world brought tears to his eyes for the first time since the ordeal began. Captain Williams continued with technical details. "Marcus, we need to remove 3 large boulders that are supporting the rock formation above you. This is delicate work that will take several hours, and we need you to move to the safest possible location while we complete this operation." Marcus used his engineering assessment of the underground chamber to identify the optimal protection point, a location near the steel I-beam that had saved his life during the original collapse, positioned to minimize risk from falling debris. He gathered his remaining supplies and moved to this position, preparing for what would be the most dangerous phase of his rescue. At 12 p.m., 26 hours after the collapse, the final extraction operation began. Marcus could hear the precise, careful work of rescue specialists using hydraulic tools and controlled explosives to fragment the large boulders blocking his exit. Each operation was preceded by warnings shouted through the rock, giving Marcus time to take cover and protect himself from debris. The work was agonizingly slow but steady. Every 30 minutes, Captain Williams would update Marcus on their progress and check on his condition. Marcus's CO2 levels were stabilizing thanks to improved air circulation, but his physical condition was deteriorating from stress, hunger, and dehydration. At 2 p.m., 28 hours underground, Marcus heard the most beautiful sound of his life. "Marcus, we can see your light. We're almost through."
At 2:47 p.m. on September 20th, 2023, exactly 28 hours and 30 minutes after the collapse that had trapped him, Marcus Rivera saw daylight for the first time in more than a day. The opening the rescue team had created was barely large enough for a person to crawl through, but it was his pathway to freedom and life. The extraction itself was carefully choreographed by the rescue team. Marcus had to crawl through a narrow tunnel carved through the debris pile, guided by rescue workers who had positioned themselves at critical points to assist his movement and ensure his safety. The journey from his underground chamber to the mine entrance took nearly 20 minutes of careful crawling through unstable debris. The first person Marcus saw when he emerged from the mine entrance was Captain Sarah Williams, who had coordinated his rescue operation. The first thing he said was, "Thank you for not giving up on me." But the person he most wanted to see was waiting just beyond the immediate rescue area. Elena Rivera had maintained a vigil at the mine site for the entire duration of Marcus's entrapment, working with medical personnel and providing emotional support to the rescue teams. When Marcus finally walked out of the mine entrance under his own power, covered in rock dust and exhausted but alert and smiling, their reunion was captured by news crews and became an iconic image of survival and love. "I promised myself I would walk out of that mine to see you again," Marcus told Elena as they embraced outside the ambulance where paramedics were preparing to examine him. "I never doubted you would," Elena replied, through tears of relief and joy. The paramedics who examined Marcus at the scene were impressed by his condition, considering his 30-hour underground ordeal. "Mr. Rivera, you're dehydrated and exhausted, and you've got elevated carbon dioxide levels in your blood, but you're in remarkably good shape," said EMT Jennifer Martinez. "Your engineering knowledge and the way you managed your air quality situation probably saved your life." Dr. Patricia Chen, the emergency physician who examined Marcus at the regional hospital, confirmed that Marcus's survival strategy had been textbook perfect. Marcus used his professional knowledge to assess and manage the technical aspects of his situation. He conserved his resources effectively, and he maintained communication with rescuers. Most importantly, he never gave up hope, which is often the deciding factor in survival situations. The rescue operation had involved over 30 personnel from multiple agencies, including state mine rescue specialists, structural engineers, heavy equipment operators, and medical support staff. The cost exceeded $200,000, but as Captain Williams pointed out during the post-rescue briefing, mine rescue operations are expensive, but we don't calculate the cost when someone's life is at stake. Marcus's engineering knowledge and professional approach to his situation made our job easier and probably contributed significantly to the successful outcome. 2 weeks later, Marcus returned to work at Consolidated Mining Solutions, where he had become something of a celebrity among his colleagues. His experience in the Blackwater mine collapse provided valuable insights into mine structural failures and emergency response procedures that would be incorporated into future safety protocols. Marcus's most important contribution came through his work with the Mine Safety and Health Administration to develop new guidelines for emergency survival in mine collapse situations. His detailed documentation of air quality changes, structural behavior, and communication procedures became valuable training material for mine rescue operations throughout the region. The thing people don't understand about mine safety, Marcus explained during a safety conference 6 months after his rescue, is that underground emergencies happen incredibly fast, but survival often depends on slow, methodical thinking. You have to use your technical knowledge to assess the situation accurately, manage your resources carefully, and maintain communication with potential rescuers. But most importantly, you can never give up hope, because there are always people working to find you.
The Blackwater mine was permanently sealed after Marcus's rescue, with the entrance area declared too geologically unstable for future development. But Marcus continued his work as a mining safety inspector, always with updated emergency protocols and enhanced appreciation for the risks inherent in underground work. The 30 hours I spent trapped underground changed my perspective on everything, Marcus reflected during a television interview on the first anniversary of his rescue. I learned that professional knowledge really can be the difference between life and death. That staying calm and thinking systematically can overcome seemingly impossible situations, and that there are always people willing to risk their own safety to help someone in trouble. When asked what kept him going during the most difficult moments underground, Marcus's answer reflected both his engineering background and his personal values. I had two things going for me. First, I understood the technical aspects of my situation well enough to know that rescue was possible if I could survive long enough. Second, I had Elena waiting for me on the surface, and I wasn't going to let a pile of rocks keep me from getting home to her.
This story, like all the stories we share on Hold On, Survival Stories, demonstrates that survival often comes down to the intersection of preparation, knowledge, and determination. Marcus Rivera's 30 Hours Underground shows us how professional expertise can become life-saving skills in emergency situations, but only when combined with the mental strength to apply that knowledge under extreme stress. The heroes of this story include not just Marcus himself, but the mine rescue specialists who worked for 30 hours in dangerous conditions to free him, the engineers who solved complex technical problems under pressure, and Elena, who provided the emotional anchor that helped Marcus maintain hope during his darkest hours underground. Marcus's story teaches us that expertise and technical knowledge are valuable survival tools, but they're only effective if combined with careful resource management, clear communication, and the refusal to give up when faced with seemingly impossible odds. His engineering background helped him assess his situation and manage life-threatening air quality problems. But it was his determination to see Elena again that carried him through the psychological challenges of being buried alive. Most importantly, Marcus's story shows us that even when we're trapped under tons of rock, isolated from human contact, and facing what seems like certain death, there's always reason to hold on. There are always people working to help us, always technical solutions to problems that seem unsolvable, and always hope for another day with the people we love. But before we go, I want to ask you guys some questions. Have you ever been in a situation where your professional knowledge or training helped you survive an emergency? If you were trapped underground for 30 hours, what mental strategies would you use to stay calm and focused? And here's an important one. Do you have the emergency preparedness knowledge needed to survive if you found yourself in an unexpected, life-threatening situation? Let me know your thoughts in the comments below. Share your own stories of professional skills saving the day or emergency situations where preparation made the difference. Your experience might help someone else who finds themselves in a survival situation where every decision matters. If this story inspired you or taught you something about the importance of technical knowledge and emergency preparedness, please give it a thumbs up and subscribe if you haven't already. Your support helps us bring you more incredible survival stories every week, and helps us honor the courage of people like Marcus who refuse to give up when everything seems hopeless. Thank you for listening to Hold On, Survival Stories. Stay safe, stay prepared, and remember, you're stronger than you know, and knowledge really can save your life.